Hello students, I welcome you all in this session of quick solutions for All India Akash Test Series JEE Advanced 2020 Test 5A Paper 1 Code C and D Subject Physics, test dated on 8th of March 2020. Straight away let's start with question number 1. Here in question number 1, a metallic rod of mass m and length L, cross-sectional area A and Young's modulus Y is arranged as shown in figure. The elongation in the rod is. Well, first we need to find the acceleration of whole of the system here. It will be capital mg. This is the weight because of which actually whole of the system is moving, and the total mass here m and m, it is 2m. So that will come out to be how much? G by 2. Now for this particular rod, the mass per unit length will be how much? It will be m by L. So taking a distance x from this end, the tension at this point, it will be m by L into x into G by 2. This is the tension here. So the stress will be how much? Divide by A. This is the stress. So elongation in this much part of the region, I would say it will be mg divide by 2AL into x. Here it is strain, so it will be extension divided by original length. So that means this will be dx, and the Young's modulus, this will be the extension of the whole of the rod. It has to be integrated from x equal to 0 to x equal to L. Here we shall have delta L, that will be equal to mg, it will be 2AYL. This integration will be how much? It is x square divided by 2. From 0 to L it will be L square divided by 2, or finally it is mgl divided by 4AY. This is the extension of this rod. So we are getting option C as the correct answer for question number 1. Now let's proceed to question number 2. Here in question number 2, a hollow sphere of mass 1 kg and radius 10 cm is placed on a rough horizontal surface after spinning with angular velocity omega is equal to 100 radian per second as shown in figure. The time taken by sphere to start pure rolling is. We need to find the final angular velocity when the sphere will be rotating in the state of pure rolling. So let that angular velocity is omega naught. So I would write down the conservation of angular momentum about this particular point, this being the initial frame, I would say. So initially it was I being how much? It is hollow spherical body, so that means 2 by 3 mr square. Original speed was omega, and about this point I would say it is 5 by 3 mr square. Let this is the final angular velocity. So this one will cancel out, and I'm getting this value of omega naught to be equal to 2 by 5 omega. So how much is the change in angular velocity? So definitely it is the retardation. So I would say omega minus omega naught, omega minus omega naught, that is the retardation. So it will be omega minus 2 by 5 omega, or that is coming out to be 3 by 5 omega. This is the change in the value of angular velocity omega. Now we need to find the torque about this point because of the friction. So I would say it will be R into Fr divide by moment of inertia would be the angular retardation. So it is 2 by 3 mr square into T will be equal to change in angular velocity that we found here as 3 by 5 into omega. This R will cancel out here, this 3 will cancel out. So we are getting the value of T to be equal to 2 mr omega divided by 5 into friction force. 5 friction force will be how much? Mu times mg. This m will cancel out. It is 2 omega r divided by 5 mu g. Put the values of these terms here. We will be getting 2 omega was 100, r to be equal to 1 by 10. This is 5. Mu was how much? It is 0.1 into g. It will be 1 here. So this will cancel out. 2, we are getting the value of t to be equal to 4 seconds. So option C is the correct answer for question number 2. Now we shall proceed to question number 3. In question number 3, the electric field in a region is given by E is equal to AYI plus AX plus BZ in J direction plus BYK, where A and B are constant. The electric potential at XYZ is given by. It is from the very standard definition of the relation between the electric field and the potential. There we know dV has to be written down as minus of E dot dr. So let's have this calculation. This is a change in potential minus E was actually AYI plus AX plus BZ J plus BYK dot product with dr. It was how much? dxi plus dyj plus dzk, or I would say dv is equal to minus of, integrate this part here, it is ay dx plus ax dy plus bz dy plus by dz. On integrating, we'll be getting this value of v to be equal to minus of, taking this two part together, this one and this one, the integral of this part will come out to be axy, and similarly the integral of this particular portion, that will come out to be how much? It will be byz. So byz and plus constant term, that will be the constant for the integration. This is the answer here. So actually we are getting minus of axy minus byz plus constant. That means option B is the correct answer for question number 3. Now we shall proceed to question number 4. Here in question number 4, a charged particle of mass m and charge plus q enters into a uniform magnetic field with a velocity v as shown in figure. Time spent by the particle in magnetic field region is. One very particular answer that we know is, if the charged particles make a complete revolution inside the magnetic field, then the time period comes out to be how much? 2 pi m divided by qb. Here in this particular situation, we'll try to find out how much angle actually the charged particle is subtending at the central point. It enters along this direction, v cross b is coming out to be along this direction, so it will move like this way and then it will leave like this one. So let this be the center. This angle was given to be 60, so this must be how much? 30 degree, 30 degree, and it will come out to be 120 degree. This angle is 120, so this one is 120 means how much? 2 pi by 3. So this one is 4 pi by 3. So actually total 4 pi by 3 is the angle the charged particle is subtending at its center. So simply I would say the time t the particle will be spending in magnetic field, that will be 2 pi m divided by qb. Here it is 2 pi and this one being 4 pi by 3. So we are getting, this is 4 pi m divided by 3 qb as the time the particle is spending in the magnetic field. So our answer is option D. Now let's proceed to question number 5. Here in question number 5, 3 rods of material X and 3 of material Y are connected as shown in figure. If rods are of same dimension, the thermal conductivity of material X is twice of that of material Y. Temperature of end A is 60 degree and that of end B is 10 degree Celsius. The temperature of junction C is. We will just consider the arrangement of these rods as the equivalent arrangements of electrical resistances. So we will try to replace the length of the rod as the thermal resistance. It's been mentioned that thermal conductivity of material X is twice of that of material Y. That means, let's say I'm writing down the thermal resistance of material X to be equal to R, then definitely the resistance of Y will be how much? 2R. Let's have the arrangement here, this being R here, then from these 2 points it will be R, R, and this is 2R, this is 2R, this is 2R, and this one will be how much? 2R. This point is A and this point being B. Here the temperature is 60 degrees Celsius and here it is 10 degrees Celsius. So looking onto this picture, it is very much sure, and now we confirm that there would not be any heat flowing across this wire. That means there would not be any heat flowing on this connecting rods. So I would say the total thermal resistance, it will be, this is 2R, this is R, that means 3R and parallel to 3R. So it will be 3R by 2 and plus R, 3R by 2 plus R. So RTS is coming out to be 5R by 2. So how much is the heat current? Delta Q by delta T, I am writing this part to be I here. It will be 60 minus 10, that will be 50, divided by 5R into 2, or it is 20 by R. So the temperature of this junction, it will be 60 minus IR. Temperature of C will be 60 minus, this one is resistance R, and I was how much? It was 20 divided by R. So temperature of junction C is coming out to be 40 degrees Celsius. So for question number 5, option C is the correct answer. Now we shall proceed to question number 6.